Hello guys, we're going to talk about chemical reactions today. Before we get too involved in the actual reactions themselves, we need to know a little bit of vocabulary. So when you see a chemical reaction, what it will look like, let me just give you a quick example here. It may have something like Bi2O5 and then an arrow and then Bi plus O2. Okay, so you might see something like that. So let's talk about the different pieces of this that we're going to be needing to know. So let's just start off with what's on the left side. Okay, the left part, guys, is called the reactants. Now, in this case, we only have one reactant, but it could be that I have something like this, SnO2 plus H2 yields Sn plus H2O. So it's possible that we have two reactants, okay? And there's possible you could have more. But most of ours are either going to have one or two. So these are called the reactants, okay? And then we have the arrow, okay? And what that means is the word yields. So the reactant yields the, and then this part is called the products. So reactant yields products. That's our vocabulary there. Now, I want to talk a little bit about the arrow. Okay, let's just start with that one. So when we look at the arrow, sometimes, and again, that means yields, okay? But sometimes you're going to see things up above that arrow. And you might see something like the word heat. Well, what is above that is what we call a catalyst, which means it is something that is needed to either start or speed up the reaction. Okay, but it's not actually a part of the reaction. Okay, so that is what a catalyst is, and we put that up above. So sometimes you'll see heat. Sometimes you might see a chemical compound. One that sometimes we use would be like potassium iodine. Okay, we have to just add that to again get it started. So whatever you see up above here, that's your catalyst. A lot of times it's heat. Sometimes it's an actual compound that you have to add to it. Okay, now in terms of our products and reactants, you're also going to see some different notation maybe out to the edge of these, okay? So maybe you'll see an S or a G, okay? Or maybe you'll see an L, okay? Or this would be a G, or maybe you'll see a Q, something of that, or CR. So those are some of the things that you might see out in front. So the question is, okay, well, what do each of those mean? Okay, so let's start with the easiest. So if I have S, L, G. Those should be very familiar to you, which means that this is in its solid form, its liquid form, or its gas form. Okay, so those are three basic ones that we see. So let's talk about a few harder ones maybe. So CR is one that you don't see, you may not have seen so far, and it is called crystal line. In other words, that might be like a salt crystal. Okay, so that might be like a salt crystal. So we might have NaCl, and then it might say Cr to the side. Okay, so a solid might be like zinc, piece of metal, and it might say solid. Okay, we might need to add water, in which it is a liquid. Okay, we might have hydrogen gas, of course, a gas. So those are three that we use. The other one that we see a lot is AQ. AQ. And what AQ means is aqueous. And what that means is that it is a solution mixed with water, okay? So you might see something like copper nitrate, okay? And then it might have AQ here, which what that means is that I took some copper nitrate crystals and I mixed them with water and I made a solution, and it's aqueous, means that it contains water in it. And that's very common. Matter of fact, a lot of the things that you use in the lab are aqueous solutions. They are solutions that I had to make up for you. Okay, so we've got solid, liquid, gas, crystal, and aqueous. I think that's all of the ones that we need to add to it. So expect to see those again in your reactions to tell you what things look like. Okay, so the next thing that we're going to talk about real quick is the types of reactions. And you're going to actually be dealing with 5 or 6 different reactions. And so the very first one that we have, okay, let's just, if I take hydrogen gas plus oxygen gas, and I put those together, and usually that will be caused by a pressure. It would be our catalyst there. We'll get water, okay, which is a liquid. So when I take two things and I put them together to make one, okay, this is called a synthesis. Now I say take two and make one. It could be that you're taking more things than just two, but our typical is here. And so the way we write it in a generic form is A plus B makes A B. So that is your generic form. Okay, our next one is actually just the opposite. We'll just go ahead and use this same thing. If I have H2O, then, whoops, that's an arrow, then I can break it down into hydrogen gas plus oxygen gas. Okay, so I can take liquid water, and this would be called an electrolysis reaction for the most part, but this is called a decomposition. So we're decomposing it, we're breaking it down. And again, it's going to look just the opposite of the synthesis. Okay, so we're going to say AB, the compound AB breaks into its A and its B. Okay, so that is 2 of our reactions. So the next reaction we're going to talk about is when I have an element, okay, and I have a compound. And this example might be something like if I have zinc plus HCl, hydrochloric acid, okay, and I put these two together, what happens is this zinc will actually come over here, and it's strong enough that it knocks off the hydrogen gas, and then it will, okay, so it knocks off the hydrogen, and it actually bonds then to the chlorine. So we have zinc chloride, and then of course we would need to do our subscripts and so forth, and hydrogen gas. Okay, and then this is will make a solid substance in the bottom. Okay, so again, what happens is that your zinc, which in this case element, will come over and attach, knock off the hydrogen and the zinc with the chlorine. Now, when you think about this, your zinc will make an anion, a positive charge, right, on there, and your chlorine will make a negative charge or an anion, and that's kind of how we know which two go together. And again, your hydrogen gets knocked off. Okay, now I didn't put the values there, but anion and cation, or cation and anion. And so what it looks like here is AX plus B. So again, A attaches to the X and the B gets knocked off. This is called a single replacement, or you'll also hear it called a single displacement. So either one. that you want to call it. Now, let's just talk a few minutes about, because we're actually, when you're doing this reaction, we also will talk about what is called the activity of metals, okay, or even nonmetals, okay. And what we have to look at is this reaction here, this zinc knocking off hydrogen, will only happen if zinc is what we call stronger than hydrogen. Okay, so in terms of electronegativity and so forth, zinc would have to be stronger than hydrogen to knock off hydrogen and attach to the chlorine. If zinc is not higher than hydrogen, this reaction will not take place, and we'd say no reaction. Okay, and let's talk about the next one. Okay, so we're going to talk about another type of reaction that we have, and this is called a double replacement reaction on that. And what happens, since it is called a double replacement, it does mean that two things are going to swap places. So here's the generic form of it, AX plus BY, and it's going to give you AY plus BX. And as you can see here, what happens is that your A will come over and bond with the Y, and your B will bond with the X. Now let's talk about why that happens that way. Remember, this is your positive, your cation, and your negative. Same way, positive comes first and negative. And so your positive has to come and bond with the negative. And again, your positive with the negative. And then that gives me my new products. So here's an example of that one. So if I had barium chloride and lithium sulfate, then what happens again is this barium, which is my positive, is going to come over and attach to my sulfate, which is my negative. Okay, and again, my lithium will attach to my chlorine. Now, one of the things I would need to do is double check, again, when you get over here, always double check your charges. So you're going to have to go to your periodic table and check what barium is. It's a +2. Check your sulfate. It's a -2. So I do not need any subscripts here. I'm going to do the same thing with lithium. It's a +1, and chlorine, it's a -1. Again, I do not need any subscripts. So this would be done. Okay, called a double replacement reaction, and usually it's pretty easy to recognize for most people. Now, I do want to go back and talk about one other thing, and that has to do with when we were here looking at our types of reactions. And I don't know if any of you questioned why, when I was doing this, I kept putting a 2 on the hydrogens and the oxygens. I think that was the only one, another hydrogen down at the bottom here. And that is because we've got to remember, on our periodic table, we had what we called the diatomic elements. Maybe you'll remember that from way back when, your diatomics. And what they meant, di means 2 atoms. And so there are elements that will never be found in nature alone. In other words, if you see one, you're going to see 2. They always have to come in a pair, just because they don't want to be running around alone. And those are, they start at 7 and they form a 7. Okay, so we have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, if you look at that, you'll see that that's actually only 6 of them. And the reason is because our other gas that we have at room temperature is our hydrogen, which is located typically over here on this side. But if you'll remember, every now and then, -1 charge. It has a plus charge over on the other side. So it also kind of fits into this category here. So 7 starts at 7, forms a 7. You just have to remember that hydrogen is your other one to make the full 7 of them. Again, they're never found in nature alone. And so when you start seeing them in reactions and they are in the product form, also when you're translating, they're in the reactant form, they must always have a 2 on them. And we'll talk more about those as we go. Okay, so those are, again, that is your vocabulary, introduction, and your types of reactions. And you need those notes in your notebook, so you'll have those to refer back to.